Oh man, let's see if this will work this time. This is take 4, I think, of attempting this. Lots of previous takes have failed for various reasons. The first one was just too long and had bad audio. I think I'm being interrupted by various factors so much that I'm just going to make 2 of these very short ones because this is actually something I'm going to talk about a fair bit. Most important thing I discovered in working on this project was algorithms, or more about their importance. And I already knew they were pretty important, but I didn't realize what an algorithm could actually consist of. So you will notice that there's no opening thing here. There's no information. Um, there's no screen. There was a bit of um, stuff in the upper corner that talked about it, but that's vanished by now. This is a maze generation thing. We had the choice in doing either a decision tree AI or a maze generator, and I decided on the generator because I'm not that great with AIs. I really like state machine types, and I had a lot of fun with them in the first few videos if you saw, but anything as complicated as a chess type AI was just too much for me. So I'm hitting it now, and it takes a little while to generate, and that is a problem with the approach I used, even though I really like some of the characteristics of it. But here we go. So, whoa, that was interesting. This was actually one of my least buggy and problematic programs, besides a couple of things where the camera jumps like that. I really like how it turned out. Most of the problems were very subtle, and that actually makes a big difference. Even if some of them were significant, and actually for what we were doing for the project and the presentation, it pretty much looked like it was flawless, and that's really important when you're presenting a project to a class or even to someone as a kind of early demo, business design type thing. So this whole thing, as you can see, pretty neat, has all these different branching corridors and stuff. This whole thing starts and all comes down to its approach. It starts with a little hallway that it randomly finds a point to create somewhere along the edge and pushes in. And then the entire thing is sealed off, creating these dark gray stone things all around the border. And this is kind of how this whole process works. All the black squares are squares that are undecided, squares that have not been changed. And once a square has been changed, they can't be changed into something else. There's actually a hierarchy that this is based on. But for an example, an open square can't turn into a sealed square, but it can do the reverse in certain circumstances. And this is just to make sure of that it's possible to reach every point in the maze. There's no sealed off points. Now, once it creates a hallway, the first hallway just creates a further opening from the front, but after that, it looks around the perimeter, and depending on how many available squares there are, it creates a random amount of possible openings, and it throws all those into a list. And if you know what the queue is, that's basically how it works. Every time it creates more of these, it will do the same thing and the same thing, constantly throwing more and more into the list. And because the earlier ones go in first and go out first, it kind of branches out and spreads fairly evenly. Now, it branches out and spreads fairly evenly, and that in itself is notable because that's sort of what the result is. And it branches out and branches out and branches out, but it never really interconnects. And I made some changes to the system to allow it to have hallways break through and create little loops. And if there are 2 adjacent rooms, it can do the same thing, like right here. And hopefully that would create potential situations where you had like to like a big round loop coming together, but this was actually the big kind of fatal flaw in my approach as well. You have this giant maze that gets more and more fine, and I created this as a multi-level thing, and that's what these yellow squares are. And yellow was a bad decision, I'll tell you right now. I should have known better. I really should have known better. But these are basically access points to the next level down. It's the first time I've seen one of those in a while. So that's a termination, it's a way down point, and the code was flagged it correctly, but it never deleted it. And that's one of the many tiny little bugs that I found. So we have like a stairway to nowhere, which is pretty cool. But as you go further down, these big bright pink ones going up, and these really hard to see yellow ones going down. As you go further and further down, you'll begin to see more and more of what the real problem is here, and you get kind of finer and finer tips. And this, it looks really cool and really awesome still, but as a gameplay thing, I would not recommend something like this. It would be a real big problem, actually. You would have to, if you went all the way down and reached this point here, and you're like, oh, well, there's nothing here. If you didn't find whatever the goal was, and there's only going to be one path out of all these possible, paths, you would have to go back up, and there's no connection to those paths over here, which is entirely possible. You'd have to go up further, and you have to backtrack and backtrack and backtrack. And as I said, I tried a breakthrough type algorithm, but there just weren't enough opportunities for it to trigger, just based on the way this maze generated. So it became a little more biased. The even spread after you started hitting a lot of termination points began to generate large parts of the maze beforehand, and didn't fill out other places till much later. And because of that, there were some issues, and the loops that you tended to get were ones for things that are being generated quite recently, because those would be the things that would be closest to each other, and the chance of two things being close to each other was not that great. I mean, you still see it all the time, but in terms of probability, it was not that frequent, and so that algorithm didn't work. There was one really fun thing about this program that I will talk about in the next video, but the main thing that I took away from this was I really enjoyed doing it to begin with. I really liked the really fundamentally simple design of how everything looked, and that's really important, because this was just really nice to look at, and it felt really easy. You could really tell what was going on. It wasn't very complicated, and that simplistic stuff that got a lot of result is also pretty important, and just that nature of it is one of the reasons why this is one of my favorite projects to do. And I will talk more about this in the second video, because I really don't want to do so many more takes again.